Polynomial. So Wes said that maybe it's when there's more than one variable, but our definition of a polynomial function is it is a function with whole number exponents and real coefficients. We've only been dealing with real numbers this year, so imaginary numbers are things that you can't do, like square roots of negative numbers. Basically, what I give you is going to be real. So, but whole number exponents, what does that mean? So let's look at some examples of whole number exponents. So examples of polynomials or non-examples of polynomials, and then I'll give you the characteristics. So an example, y equals 2x plus 7. That's a linear function that we've studied this year. That is a polynomial function, but it's called linear. Y equals x squared plus 7x plus 1. So quadratics, that fits under this family of functions. What about just a constant function? Y equals 3. So constant functions fit in here. And even bigger functions like y equals x to the 5th plus 7x, something like that. So our powers are the whole numbers. So 2 to the x, or 2x, that has a power of 1. X squared has a power of 2. 3 by itself actually has x to the 0 power sitting next to it. You just can't see x to the 0 power because anything to the 0 power is 1. X to the 5th. So some non-examples would be like our absolute value function, our square root function, our exponential functions. Or if you had x to the negative 2nd power, x to the 1/2 power, those are not whole numbers. So do you kind of see what these examples have in common with each other and how the non-examples are different maybe? Because the first big idea is, can you just identify, is this a polynomial function or not? What's wrong with it? So these are kind of all kind of wrong things. They're all functions, they're just not polynomial functions. Here's all kind of examples of right things. And then the characteristics of a polynomial function are that you write them in standard form, right? In standard form from high to low exponents. And they are all a smooth, continuous graph. So you always write them in standard form from high to low, like x squared goes first, then x, then a constant. They're always going to be smooth. What do you know about the absolute value graph? It's a jagged V shape. What do you know about the square root graph? It stops at 0 and then goes forever as a curve to the right. So this goes on, they're smooth and continuous. So just by looking at a graph, if I showed you an example, like this is something we're not studying this year, but that's a rational function. It's not continuous. I have to lift up my pencil to do this side of the graph. This is not smooth. There's a jagged change in direction. So these are not polynomials. Some of the other polynomials, you know, that's a smooth curve. That's a polynomial function. That's a smooth curve. It's a straight line, but that's a polynomial function. So starting to think about this as a big family of functions. And I'm not going to ask you a lot of definitions, but I'm going to ask you questions that you have to know the vocabulary in order to answer the question. So you have to know what a degree and leading coefficient are in order to answer questions about polynomials, but I'm not going to ask you to define what does the word degree mean. I just want you to be able to state the degree of a function if I give it to you. The degree is the highest exponent, and the leading coefficient is the coefficient or the constant in front of that highest power term. So the degree is the highest exponent, and once you identify that, you can find the leading coefficient. So it's whatever's in front of that term. And so this would be kind of the first objective on your quiz on Friday, doing one of these problems down below. It says first identify, is it a polynomial? Then write it in standard form and state the degree and the leading coefficient. If it's not a polynomial, circle basically the problem. What's wrong with it? In all of these, there's only one that's a problem. Can you identify which one of these functions, 1 through 4, fails as a polynomial? Only one of them fails. There's a lot of tricky things, but one of them has a failure. Yeah. Yeah, what's wrong with number 4? Right, so it has a fractional exponent. So this one is not a polynomial. What looks a little bit sketchy in number 1? The pi number. So pi is a real number, it's just irrational. Pi is 3.14159. So this is actually a polynomial. That's a real number, it's irrational. All right, so if we were going to put number 1 in standard form, I would put my 2x cubed first, then my 2x squared, and then minus my linear pi x last. So that's putting it in standard form, which you've been doing this for quadratics literally last unit. So I don't feel like it's something new. We're just applying it to higher powers. The degree of this function is 3, and the leading coefficient, what's right in front of that, a number 2. Whether you write y equals or f of x, doesn't that just mean y equals, right? So that's still a function. I just need to switch the order of these two terms. The negative 3 comes in front of x to the 7th, right? So I'm going to rewrite this as negative 3 x to the 7th plus 2x. Because I have to put the highest term first, and whatever the coefficient follows it. So the degree of this function is 7, right? Degree is 7. Leading coefficient is negative 3 because it's what comes in front of it. It's leading the whole equation when it's in standard form. See how it's leading? In number 2, the original format, it wasn't leading the function, right? I had to put it in standard form for it to be at the lead. And then this last one actually is already in standard form. 1/2 is a fraction, but I'm allowed to have it as a coefficient. I'm not allowed to have it in the exponent. So see how in number 4, half is in the exponent? And then the square root of 3 is an irrational number, 1.7. Do you see how the x is outside of the square root? If the square root had gone all the way over the x, then it would have been not allowed. But that x is on the outside. So this is the square root of 3 times x. So this is allowed. It's just kind of a tricky one. So you really have to know the definition. Whole exponents and real numbers as your coefficient. So your degree is 3, and your leading coefficient would be what for this problem? 1/2. All right, so that was skill number 1. So I would like you to jump to, oh, did I not give you guided practice? I guess I didn't give you guided practice on this somewhere else. You have to name them. All right. We'll just move right on to the evaluating. So this is kind of skill number 1 for your quiz, right? Identify, write it in standard form, state the degree and leading coefficient. This second step, we've been doing all year long. It's function notation. You plug whatever is in the f of x, you plug that in for x in the function and see what you get. So we've been doing this with all of the functions all year long. So plug into all of these x's on the right-hand side and see what you get as your output, input, output. Think about how far you've come. At the beginning of the year, some of you did not know how to do function notation. But we've done it for linear, quadratic, and now polynomial. Plug it in and see what you get. I'll give you a minute to write your answers. Use a calculator if you need it. What I get here. So when I plug in 2, 2 cubed is 8, and then I'm subtracting 2 and adding 1. So does that come out to 7? 8 minus 2 plus 1 looks like comes out positive 7. All right, and then when I plug in negative 1, let's see, negative 1 cubed is still going to be negative 1, right? Negative 1 times negative 1 times negative 1 is negative 1. Here's a tricky part, negative x. So that's negative negative 1, which turns into positive 1, right? Because it's the opposite of x. And then I'm adding 1 at the end. So this is adding 1. So negative 1 plus 1 plus 1 looks like it comes out to just 1. And then f of 0, this would go away, this would go away, and you would just get 1 as your output. Right? Input, output using function notation. You never plug it in on the left-hand side because that's y equals. So you just plug in what you want for x and you generate the output, and you could use a calculator. All right, I already filled in all of the names for you so that you wouldn't have to write them today. In past years, I had you write all these names. I think you're pretty familiar with constant, linear, quadratic, and cubic. Cubic is third degree. Quartic might be a new name for you. So quartic might be something that's new. And then above that, you would just say fifth degree, sixth degree, seventh degree. There's no special names to remember. And then I think you're pretty familiar with what a monomial, binomial, and trinomial is. Right? 1 term, 2 terms, or 3 terms. So the only new word is really anything that has more than 3 terms we call a polynomial, which gets a little bit confusing, right? Because even this, like y equals 2x cubed, there's only 1 term there, but that's called a monomial, and it falls under the family of polynomials. So poly doesn't have to mean more than 1, right? It just means that it falls in the family, but in this case, they're using polynomial to mean 4 or more terms. So it's kind of used 2 different ways. So don't let that confuse you. Oh, I'll just finish this part first and jump back up to the top. A binomial, that's 2 terms, right? Like x plus 7, right? We've been multiplying a lot of binomials in quadratics. So it just means 2 terms that are separate from each other. A trinomial could be like x squared plus 3x plus 5, right? It has 3 separate terms in the function. And then polynomial, could be like x to the 8th plus 2x squared plus 3x plus 7 or something like that. It has more than 3 terms. So I can't call it a trinomial anymore. So that's just a 8th degree polynomial. So that's identifying how many terms. So when you get down to the bottom, that's half of its name. You know how we all have a first and a last name? Or most of us do. Some of us have middle names, but first and a last name. All of these functions have a first and a last name. What is their degree? So that's this name. And what is how many terms do they have? Have you ever done I don't know, there's like social media quizzes when it's like, find your elf name by the first letter of your name and your birthday, and it makes up your name as peppermint enthusiast or something like that. I don't know. We're making up a 2-part name for each of these polynomials. All right, so then a constant function is like y equals 3, which I wrote on the front page. That's a straight line, horizontal straight line. Linear function, we spent a whole unit. I hope you can identify 1/4 x minus 3 as a linear function, y equals mx plus b. I hope to God you can find quadratic functions, right? Like y equals x squared, it's a quadratic. A cubic function, y equals maybe x cubed plus 2x. I'm just throwing extra terms on because that doesn't change the degree. It's still x cubed, even though it's a binomial. Quartic would be 4th degree, like 5x to the 4th. 5th degree, x to the 5th plus 2x squared plus 9. right? I'm just looking at the highest power. So anything that comes after it in standard form doesn't add to the degree. So this is 5th degree, 4th degree, 3rd degree, 2nd, 1st, constant. So do you see that's your first name and your last name? Like a quadratic binomial. So what would be this first one down below? What's number 1's name? What would you call that? So give it a first and a last name. Give it a name from the first table and a name from the second table. So I would call that, it's a quadratic, and there's 1, 2, 3 terms. So I would call this a quadratic trinomial. So we're just getting used to some vocabulary that we haven't really used, just so we can talk about these functions. Try 2 through 5 together on this unit. So number 2 is linear, right? X is linear, and it's a monomial. So this is kind of like, objective 2 on your quiz. You've got to be able to identify if it's a polynomial and put it in standard form, and then you have to be able to name it. Maybe we'll do a warm-up like this tomorrow, like an entry ticket quiz that's practice on these couple objectives and see what you remember from today. This is what your homework will help you practice, homework 5.1. Number 3, that is a cubic, and it's a binomial, right? 2 terms. This is a quartic because it's 4th degree. And again, it's a binomial, right? 2 terms. What'd you say about number 5? So you weren't thrown off. This is not in standard form. Cubic is the highest power, right? So it's cubic and it's a trinomial. So none of these needed to say polynomial, but if there were 4 terms, I would have said it's a polynomial. So this is like a resource, right, for your final exam. So that way you've got, you don't have to memorize all this, but for this unit, really the only new word I think is quartic. And I'm going to list for you like a word bank on the quiz. So name it by degree. I'll list constant, linear, quadratic, cubic, quartic, etc. And by number of terms. I will list monomial, binomial, trinomial, polynomial, right, on the quiz. So we're getting used to this vocabulary. Okay, then the last objective for today is we're going to add and subtract and multiply. We've already done this with quadratics. So it's just adding like terms like you did with quadratics, but now there might be a 3rd or 4th degree term. And there's this kind of funny looking notation. So you can add 2 functions together separately, or you could use function notation to say that you're adding 2 functions together. See the little plus sign or the minus sign or the multiplication symbol? All it means is add them, subtract them, or multiply them. So I didn't write it that way in these examples. Here I'm just showing that you're adding them together. But when you look down below, see how it says F plus G? See, you're just grabbing F from here and you're grabbing G from here. So just getting used to how they might write it. So I'm going to do the 2 examples for you, and then I want you to try them. You got to stay really organized. So I'm adding together 2 parentheses. To me, the parentheses don't matter. If I'm subtracting 2 parentheses, before I start, I'm going to distribute the subtraction symbol. But if I'm adding things together, I don't have to distribute anything. So I'm going to look for the highest term. It looks like the highest term is the cubic terms, right? I have a 2x cubed, and I have negative 4x cubed. So how many do I have? Negative 2x cubed. Are you with me? I just added the coefficients, kept the x cubed the same. I like to cross out as I go so that I don't miss anything. What's my next highest term? It looks like this 3x squared is the only x squared term. So plus 3x squared, cross out that term because I used it. It looks like my next term is negative 3x. So minus 3x, cross out that term. And then I've got a positive 4 constant and a positive 17 constant. So that would be positive 21. So this is my new function that I built by adding those two functions together. So we're going to do the same thing with subtraction, but before you start, I highly recommend distributing a negative sign. So I'm going to write this as negative 4x squared minus 10x and minus 3x cubed, because all of them were positive. So I'm changing all of them to a negative. I'm just going to write that underneath. So I'm only looking at these terms, and I could just like circle them, and I don't have to forget about distributing. All right, what term would go first in all of these? What's my leading term? Yeah, so 5x to the 6th. I used it, so I'm going to cross it off. All right, what's my next highest? It looks like the x cubed term here and the x cubed term here. If you have -3 of something and you subtract another 3 of something, now you're at -6. So I have -6x cubed. Cross out, cross out. What happens to our x squareds? I have +4 of them and I have -4 of them at the same time. So that adds up to 0, right? Gone. And then it looks like -10x minus 20 to finish out that function. See how you take your time and you cross out each term? You're not going to miss anything. Don't go too fast and do it all in your head. There's no sense. All right, so you're going to try examples 3 through 6 the same way. And if it helps you to actually write out the functions so you can cross them out, like example 3, maybe you can do it all in your head. Maybe you want to write out this function and then add this function so that you can cross it out all under example 3. So you're going to add f plus g, then you're going to add g plus f, and then you're going to take f minus g, and then you're going to subtract g minus f. And then down here I said, what operation is commutative? Does anyone know what commutative means? It means it's the same forwards and backwards. So is addition or subtraction going to be the same forwards and backwards? 2 plus 3, 3 plus 2, doesn't that come out to 5? But what about 2 minus 3 or 3 minus 2? Right, so addition will come out commutative. So maybe that'll save you time on one of the problems. Oh, it's the same forwards as backwards. So see if you can add and subtract, and then we're just going to try multiply. 5 and 6, because I can't do it in my head. So I wrote out 2x squared plus x plus 4, and then I'm subtracting this function. So it's minus x squared and plus 9. And then when I switch the order, I write my x squared plus 9 first, and I'm subtracting this entire function. So negative, negative, negative. That way I'm looking at them and I don't make the mistakes. To me, subtraction is harder for students because they don't want to take the time to distribute that negative sign. So this is called operations, and we're going to spend some time practicing it again tomorrow. The last operation, can I turn the page? Not quite. The last operation is multiplication, and that's where we end today, and then you can jump over to homework 5.1 to see if you've got it. Might be able to get that finished. Guess what? We've already learned how to do multiplication. I said remember FOIL or remember the box method. I guess this year we did more of the box method. So example 7, this is like right off of the test that you just took on quadratics, right? You take 2x minus 3 times 2x minus 3, and you write your answer inside that box. The only difference between 7 and 8 is you have a bigger box because you're going to have x plus 2, and then you're going to have x squared plus 3x plus 1. So you just have a bigger box on example 8. Hold off on example 9 for a minute because it gets a little bit bigger. See if you can do example 7 and 8 because you already know how to multiply, right? Maybe the only one you don't know how to multiply is when there's like x squared times x. That would become x cubed. Everything else you've multiplied before. So take a minute and try 7 and 8 multiplying on your own. Know how to write your final answer, right? Your final answer in standard form would be 4x squared minus 12x plus 9. So always take your box, combine your like terms, and actually write your final answer. So you're trying example 8. And then I think I'll show you example 9, but maybe we'll do example 10 as a warm-up next class for the people who were absent. So, did you already finish example 8 or are you on it right now? On it? Okay, I'm going to wait another minute combining like terms. Just x cubed, you should have had a 3x squared and a 2x squared, which adds together to give you 5x squared. And then you have a 1x and a 6x, which adds up to 7x, and then plus 2. Did anyone get that all right? You got it? Okay. So why is x plus 4 cubed different? It's basically going to be the same type of problem as example 8, but we need to work out one of the x plus 4 binomials first. So see how there's 3 of them? So what we could do is we can leave this guy by itself because that's going to be the side of our box, but we need to first multiply out these x plus 4 to make them a trinomial. So the trinomial, to save you that step, x times x would be x squared. So I'll have x plus 4. Do you see how my outer and my inner term would be 4x if I had done the box? So 4x plus 4x is 8x, and then 4 times 4 is 16. So you have x plus 4 that you're going to put down the side of your box, and then you have this x squared plus 8x plus 16 to put across the top of your box, like in example 8. So for your last problem for today, why don't you try that last box one, and we'll save 10 because it's a 3 by 3 box on example 10. We'll save that one as a warm-up tomorrow. X squared 8x 16. You might need a calculator on example 9 to multiply some of the bigger numbers. That's okay. So take a stab at example 9. I'll give this one so I can finish my video here. Would be x cubed 8x squared and 16x. So basically the x increases them each by a power of 1. And then the 4 multiplies the coefficient. So 4x squared, 32x, 64. So do you see how on the diagonals you end up with your like terms? So you have x cubed plus 12x squared plus 48x and plus 64. And that's probably the biggest multiplying problem I would have you do. I threw a 3 by 3 on this worksheet for a warm-up tomorrow, but that's like the biggest.